Alright, we'll try this again. It was totally out of focus the last time. But here's this little silly LED Christmas tree thing I've been working on. And you may or may not know that it's the nightmare before Christmas, because there is no information on the internet or even from the manufacturer of what all these components should be. Yeah, there's plenty of information to say what they might be. So before I built another one, and this was the first prototype where the power on-off switch here was burnt out and useless, hence the yellow bit of wire that basically doesn't do anything but keep the thing going, and it's been running off a USB cable plugged in, let me get the water jug out of the way, to this thing that basically says it's not drawing any current whatsoever, which is good, because if it's running on batteries, the 3 AA's underneath should last a while. But I was thinking, I mean, I looked on the internet and I found even the circuit diagram here. Oh, let me stand up. Ow. I don't know if you can actually make that out. But the circuit diagram says 22 microfarad capacitors, 10k, nothing, 10k, a bunch of LEDs, another bunch of LEDs, and so on. And then the LED on the top of the Christmas tree is just connected between power and ground and a 2.2k resistor. So I thought, well, everybody is moving, changing, trying different stuff. So I thought, well, why not breadboard it? So I did. I built basically one channel, if you like. Looking at this tree, basically what I built was this one half. And I also reduced the number of LEDs per sector, because they had, I think it was 6 per branch, but I only used 5. And powering it off a 9 volt down to 5 volt, which would be the same as a USB charger. And then I went in to change a few things. Somewhere in here there's the 47 microfarad capacitor, but the circuit diagram calls for, I don't think it's focusing, 22, and so on and so forth. And all the resistors provided in the package didn't match up to anything on the schematic. So I think there was a couple of 330s, a couple of 470 ohms, and maybe a couple of 2.2Ks and a bunch of 10Ks, and that was it. So there were actually no 1K resistors in there. Like, this means a whole lot to all of you guys, but it means a lot to me. Here's the other cap, and there's the first one, second one, and down here somewhere is the third one, which to relate to this is the first one, the second one, and the feedback to the third one. Now, as the power charges up this capacitor, it energizes this transistor and allows current to flow, so the lights go on. But as it discharges into this capacitor and lets this one go, and so on and so forth. So, changing the resistance of the 1Ks, the LED brightness, all that really did was increase the current. Didn't really change the brightness, which is a shame. And increasing the current was stupid because, you know, people might want to run this off batteries. So why draw more current for no reason whatsoever? So while I'm on the subject, this little breadboard kitty, this is called a RAB platform, whatever the heck that means. I thought when it arrived it was quite cool. You know, it's got a recessed place for the patch board, recessed place for the Raspberry Pi, recessed place for the Uno Omega. Then today I decided to use it to do this little demo with, and found out if you screwed it into its normal position, there is no way in hell you could actually plug a micro USB to power up that Arduino Uno. So I had to put the whole bloody things on little standoffs, and I'm sure the same thing will, can I get it around here? I'm sure the same thing will apply here when I try to plug in a micro USB. A big plastic thing over the plug will stop it plugging in. Great idea. Stupid engineers. Bye. And this is trying Rob's old camera because it seems to do macro much better than mine. So I'll just try and show you these capacitors again. This one here, let me get my finger in the way. It's capacitor 1, then capacitor 2, which then, as I showed you on the circuit diagram, loops back to form capacitor 3. Let me get a bit more light on here. Maybe too much light now. But that's a better close-up, I think. And I've readjusted this standoff for these things because they look just stupid sticking up in the air, so I've just added a nut on the back side of the screw, so now it's pretty much flush with the housing, but now it doesn't stick up in the air, stupid mode. Alright.